Okay, for what we have in this problem, we are now looking at determining the length of a curve. And we have representing the curve is the function y is equal to 2/3 of the quantity of x squared plus 1, which will be taken to the 3/2 power, and this will be as x goes from 0 to 3. And as we look at the determination of the length of the curve, first of all we need to be able to take the differential of both sides, and we have that y is going to go to dy, and there's a lot of work that's going to be involved for x. Okay, we have in terms of the power rule, we have 3/2 times 2/3, and the degree of 3/2 is going to be lowered to 1/2, and so you have the 3's and the 2's will cancel out. And also, since x squared plus 1 has a derivative that will not go to 1, we have to chain this portion out, and we have for the derivative of x squared plus 1, okay, this will go to 2x. And so for carrying forth what we have here, we have 2x times what's going to be the square root of x squared plus 1 dx. So we have lined up directly our differential terms, and thus the derivative dy to dx is going to be at 2x times the square root of x squared plus 1. And as we square this derivative, okay, you're taking the square of both 2x and the square root of x squared plus 1. And so we have in the setup here, upon squaring, 2x will go to 4x squared, and we have the radical freed up, so we have 4x squared times x squared plus 1. And so we have for the square of the derivative, we have 4x to the 4th plus 4x squared. And setting this up so as to determine the length of this curve, okay, from point A to point B, again we had the lower and the upper limits of x at 0 and 3 respectively, and then we have integrating over the square root of 1 plus the square of the derivative. Okay, we have filling in the numbers and the terms. Okay, we have 0 to 3, 1 plus 4x to the 4th plus 4x squared. And if you take this trinomial and arrange the terms in descending degree order, we're going to end up with a perfect square, okay, where we have the square of 2x squared plus 1 dx, square root of the square of 2x squared plus 1, okay, simply goes to the inside terms. And so we have leading up to rather simple integration exercise where we are down to the power rule of integration. And so we have for the antiderivatives, we have 2x cubed plus x, and as x goes from 0 to 3, applying the numerical integration, we end up with 18 plus 3, and so we do have at 21 for the length.